Right, welcome to another presentation from LIDNUG, Link.net Users Group. This evening for me, lunchtime for you guys in the States, we have Jeff Processi from Wintelect, and he's going to tell us all about what's new in Windows Phone 7.1 Mango. And this is one that I've been looking forward to. As usual, we have the normal run-of-the-mill stuff first. Big thanks to our sponsors. I apologise if any of them are watching and there's a couple of images missing. The Oxweb one should be there as well, but we have a corrupted image, so I wasn't able to repair that in time. And Telerik, who, between the pair of them, keep LIDNUG.org online for us. We have our usual rundown of links and things. You can find the official group on LinkedIn, group ID 43315, or search for LIDNUG. And you can also visit us at www.lidnug.org. We have our calendar in various feeds, as you can see there, and lidnugevents.eventbrite.com is our official events portal. You can follow us on Twitter and Facebook, and info@lidnug.org will get an email to any member of the team, as well as contacting them or interacting with them in LinkedIn. We don't have the usual upcoming events slide, I'm afraid, because I've just had to put these together at the last minute. But our next event is Scott Guthrie Unplugged, session number 9. That's scheduled for September the 22nd. 10 AM Pacific Standard Time, and that will be his usual mix of FAQ goodness where you can just rapid fire his questions at him. Without further ado, I shall now hand over to Jeff, who I think is sitting waiting in the wings.
I am here, thank you. I'm going to change over to a set of slides that I prepared for this presentation, and let me just welcome everyone who's here today to hear about Windows Phone 7.1, also known as Mango. Lots of things happening in the Windows Phone space these days. Windows Phone, as we know it, is still fairly young, as you're well aware, and some folks at Microsoft have been working very hard in recent months on the next version, which is popularly known by the name Mango, but is officially known as Windows Phone 7.1. I'm particularly excited about this release because it has lots and lots of new stuff in it, not only for consumers but for developers as well. From a consumer standpoint, it's important, if this platform is going to succeed, that the phone have lots of compelling features that would draw users in, and there's certainly no shortage of those in Mango. Some of my favorites are the ability to set up groups among your contacts and to aggregate content from various social networking sites for those groups. As an example, I've created a group named Family on my Mango phone. In it, I've placed my wife and my 3 kids. All of them are on Facebook. Some of them are on Twitter and other social networking sites. So without having to open the Twitter app or go to Facebook or something like that, I can just go to that family group I've set up, and it pulls in all the content that my kids and my wife are posting in various places, all the pictures, all the status updates, all the tweets and everything else, and I just see them all right there in one place. Another exciting thing from a consumer standpoint in Mango is that we finally support custom ringtones, which, believe it or not, is a very big deal to consumers. In fact, not long after Windows Phone 7.0 was released, I visited my local AT&T store, and I spoke to the manager there, and I said, so are you selling lots of Windows phones? And he said, yeah, we're selling quite a few of them. And I said, are people happy with them? His response is, yes, but we've had a few of them returned. And I said, oh. And out of curiosity, why are they being returned? And he said, well, the most common reason for having the phones returned is that users get them home, find out it doesn't support custom ring phones, and they don't want the phone anymore. So quite smartly, Microsoft has built custom ringtone support into Windows Phone 7.1, as well as lots and lots of other things to make the platform more pleasing and more compelling to end users. That's about all I'm going to say about end user features, because the focus of this presentation is on what's new for developers, and there's lots and lots of new stuff there as well. There's also several new tooling enhancements that make life as a developer with Windows Phone better. There's an improved emulator. I'll say more about that later and even demonstrate some of the improvements for you. There's a new code profiler, making it much easier to do hardcore performance analysis of your phone applications. There's a new tool for exploring what's in isolated storage. You can pull isolated storage from a real device or from the emulator so you can see exactly what's in there. It may not sound like a big deal, but it's a really big deal given that one of the biggest and most important new features of Windows Phone 7.1 is HTML5 support. Increasingly, developers are wanting to build an application once and have it run on multiple platforms, not only Windows phones, but iPhones, Android devices, iPads, and other things. The tool that we use to build cross-platform applications is HTML5, and now that HTML5 support is present in Windows Phone 7.1, yes, we can build HTML5 applications that run on a variety of platforms and run them on Windows Phone. In fact, I'm going to demonstrate that for you in a few moments, and I'm going to put that sample and all the other code samples that I'll be presenting in this presentation online so that you can pull them down and play with them for yourself. In fact, towards the end of the presentation, I'll give you a URL so that you can pull these samples down. So there's lots to talk about, and I would suggest that at this point we just get right into it. What do you as a developer need to know about Windows Phone Mango? Well, I put this little chart together here just to highlight in summary fashion a lot of the new features. HTML5 support is a very big deal. Not only can you browse HTML5 websites in the built-in browser, but if you're a developer and want to build cross-platform mobile applications using HTML5 as the substrate, well, the heart of IE9 is now present in the web browser control on the phone, and we can therefore use HTML5 to build cross-platform mobile applications that run on this platform. Socket support is new. There's support for not only TCP sockets, but UDP sockets as well. One of the less well-known features of Mango is that you can make UDP connections to other Mango devices sitting on the same network, on the same subnet, and you can do UDP multicasting to them. What does that mean? That means that if you wanted to build a team game so that people sitting in the same room or the same office or something can connect their phones directly to each other and have them communicate, they may do that without having to go back to a server, using it as sort of a central go-between. There's also a pretty high level of integration now between XMA and Silverlight, so that if you want to use XNA content in your Silverlight application, you're now free to do that. You may recall that in Windows Phone 7.0, that was pretty much an either-or proposition. You could use XNA or you could use Silverlight, but you couldn't use both on the same page or in the same application. There's lots more as well. We're going to talk about a couple of new APIs for integrating with data stored on the phone, like the user's contacts list and the user's calendar. There's a new component called the local database. It's actually a derivative of SQL CE. You've always, at least since version 7.0, been able to store data locally on a phone by writing it to isolated storage, which was sufficient for a lot of needs. But if you had a need to store complex relational data locally on the phone, there really wasn't a way to do it. You had to gin something up from local storage. With the new local database, we can write relational data to isolated storage on the phone, perform queries on it, and all that to pull the data back out. Some of the other things that you see kind of scanning this chart right here, secondary tiles and deep linking. That's something I'm going to talk quite a lot about and show a demo. It's one of the more underrated features, I think, of the new platform, but also one that can be really interesting to developers and very compelling to end users. In terms of multitasking and application lifetime, there's some big changes there. You may know already that the execution model, the application lifetime model, changes in a big way and in a good way on Mango. I'm going to say a lot more about that in just a moment. And in response to developers telling Microsoft that they would like to be able to do background processing in their applications, Microsoft has added several new multitasking features in. While it's not strictly true that you could just write an application that is just always sitting there running in the background, it is true that you can leverage something called background agents now to perform periodic processing in the background. To play background audio, if you want to build a music player type application, for example, and you wanted to be able to play music even when it's not the application in the foreground. Or if you want to do background file uploads or downloads, there really wasn't a way to do that in Windows Phone 7.0, but thanks to the new background file transfer agent in 7.1, you can do that. One other thing with regard to multitasking and application lifetime is something called alarms and reminders. You've undoubtedly seen those on your phone before. If you're using an Exchange server, for example, to get your email and your calendar, a reminder will pop up when a calendar appointment is about to come due. In 7.0, there was no way to build those kinds of alarms and reminders yourself, but there is a new API, actually a pair of APIs, that allow us to create alarms and reminders and have them pop up, even allowing them to deep link into an application so that if the user sees an alarm or reminder that you've created and touches it, it can launch your application and pass state into it so that it can initialize itself into a particular state. One final category of new stuff in Windows Phone 7.1 is a whole bunch of new sensor APIs. For example, all Windows phones today have an accelerometer in them that allow you to build labyrinth-type games, the games that are popular on iPhone, for example, where you roll a marble through a maze and try to avoid holes and traps and things like that. Well, of course, Windows Phone 7.0 had a pretty cool and pretty easy-to-use accelerometer API that allowed us to integrate with that sensor. But future Windows phones are going to have additional types of sensors in them. Most of them are going to have compasses, for example. Some will have gyroscopes. And there are new APIs to complement those new sensors. There's also a new API that sort of integrates all of the various sensor APIs into one. We sometimes refer to it as the Motion API or the Integrated Motion API or Consolidated Motion API. And I'll be talking a bit about that as well. One final thing that I'll be saying at least a word or two about is the new low-level camera API. There was a very limited camera API in the first version of Windows Phone. It was actually something called Camera Capture Task. You could allow the user to snap a photo, then you could bring that photo into your application. But in the first version of Windows Phone, if you wanted to do something more sophisticated, like you wanted access to the individual frames coming through the viewfinder, or you wanted to do something else, maybe snap 3 pictures instead of 1, so you could do some HDR processing on them, for example. That low-level API did not exist at the managed code layer in Windows Phone 7.0, but it does exist in 7.1. So the bottom line is it enables a whole new kind of application that formerly only OEMs could write. Now, that's a lot of stuff there, and some of these features we'll be talking about in detail. Some will be just talking about at a very high level. But what I'd like to do for starters is talk a little bit about a feature called fast application switching. In Windows Phone 7.0, you may be aware that the execution model for applications was very much a one application at a time model. And that's still true to some extent in Mango, although with all the new background tasks and background agents, there are ways that we can write code that runs in the background. But one of the downsides to the one application at a time model in 7.0 was the fact that in the vast majority of cases in 7.0, when the user switched from one application to another, the previous application was completely terminated. The threads were stopped, the process was terminated, the image was removed from memory. There are actually reasons Microsoft decided to do that in version 7.0. And one of the big reasons was that the processors on these phones are very limited compared to the processors that we're accustomed to in our desktop machines and even our laptops. And there was some genuine concern at Microsoft that if applications were allowed to just run in the background and compete for CPU cycles, it may make foreground apps feel really slow and be harmful to the platform as a whole. But there are other reasons that Microsoft decided to rethink this just a little bit. For example, an application that manages quite a lot of state, maybe an image processing program that's storing I should say multi-megabyte bitmaps in memory, had to use something called tombstoning to preserve that state if the user switched away from it and then switched back to the application. Not only did that complicate life for programmers, but it also degraded the user experience some, because once that application was switched back to, it might take several seconds for it to actually restore itself to the state that it was in before. The crux of fast application switching is simply this. In most cases in Mango, when the user switches away from an application, that application is not terminated. It is suspended. That is, its process image remains in memory, but the threads inside it are suspended, so they're no longer running. But if the user then presses the back button, for example, to go right back to that application, the application can be resumed almost instantaneously because it doesn't have to take the time to untombstone its data. Now, most of this is something that end users will notice. They'll notice when they switch back to an application, for example, that it will resume a lot faster than it did before. In fact, it may resume instantaneously from the user's perspective. There's not a whole lot that a developer has to do to leverage this. In fact, technically you can get away with doing absolutely nothing because code written to do tombstoning and untombstoning of data for 7.0 will just work in 7.1. But as a developer, there are some things that you should do in your code. For example, when the user switches away from an application, if they then switch back to it, and your code doesn't take a moment to determine whether it was made dormant, that is, it wasn't terminated, rather it was just suspended, it may needlessly untombstone a bunch of data that doesn't really need untombstoning. So what a developer needs to know about fast application switching is how it affects him or her, what minor changes you need to make to your code to take advantage of this new feature. Now, I wanted to show you a demo, but before I do that, let me mention a couple of things. Remember that when I use the term dormant, that's new to Mango. That means a process has been switched away from, but it has not been terminated. It's still sitting there in memory. All state inside it has been retained, but its threads have been suspended. You may be aware that in Windows Phone 7.0, events are fired at the application level when an application is started up or closed, and also when an application is activated or deactivated, which was the terminology at that time that we used to refer to applications that have been switched away from and then restarted or reactivated. Well, dormancy, or the dormant state, is a new state in Mango, and there is an application level event that's fired to tell you that an application that was dormant has been switched back to. In fact, it's not a new event. It's the old activated event that you may be familiar with from 7.0. Basically, when your application is switched back to an activated event fires, you can write an event handler for that if you want in app.xaml.cs. But how Mango changes this a bit is with the new isApplicationInstancePreserved property of the activated event args. When your application is reactivated following deactivation, you can check that property. If it's true, that tells you you don't need to do any untombstoning of your data because the process was not terminated. It was just made dormant in memory. If, however, you find that that property has been set to false, then you need to untombstone your data. So one really important point to take away from this is that we still have to write the tombstoning and untombstoning logic in Mango that we wrote in 7.0, because there's never a guarantee that when your application is switched away from or deactivated, that it will simply be made dormant and not terminated. However, in most cases, it will be made dormant. So with a little check like this one in your code, you can avoid untombstoning data that doesn't need to be untombstoned. Now, while this property was added specifically for that purpose, in real life, you're probably never going to need it. There's actually a simpler way to find out following reactivation whether you were made dormant or you were actually terminated, and I'll show you that in my next demo. But before I get into that demo, there's one other thing that I need to show you. As I said, it's still important to build tombstoning and untombstoning logic into your phone apps in Mango, just as it was in 7.0. Again, when the application is switched away from, you're never guaranteed you'll simply be placed in the dormant state, although in the vast majority of cases you will be. In fact, you can even see in the emulator, oftentimes when you're testing your app, even in the absence of tombstoning code, if you switch away from it, then switch back, you'll find the state has been retained, which is a good indication that you were simply made dormant rather than terminated. But that also means it's going to be hard to test your tombstoning code. Somehow, some way, we'd like to have a way to force an app to be terminated when the user switches away from it. And that's why in Visual Studio 2010, once you've installed the Windows Phone 7.1 SDK, if you go to the properties for your Windows Phone project, you'll find a new checkbox there that reads Tombstone upon deactivation while debugging. That box is not checked by default, but once you check it and you run your code in the emulator or on a device for that matter, as long as it's a debug run that you're doing, anytime the app is deactivated, it will be terminated. That gives you a chance to test your tombstoning logic, realizing that once the application is actually deployed to a phone, that logic may never be exercised. Or, then again, it may. You never know. So here's what we're going to do to demonstrate this. I'm going to share out my desktop here for just a moment. And I'm going to bring up Visual Studio. I've already installed the Windows Phone 7.1 SDK, the RC version, which was released just a couple of weeks ago. And I'm going to start by opening up a project. This is one of the projects that I'll make available to you at the URL I'll give you at the end of the presentation. It's actually a very simple project. It's called Input Scope Demo. So I'm going to open it up, and then I'm going to fire it up in the emulator so we can see what it looks like. So let me do a Control F5, and we'll get that up and running. It says there were deployment errors. That's probably because I need to rebuild or clean the solution after moving it from one location to another on the machine I'm doing the presentation from. So I'll do a rebuild all, and it should work this time around. Let's try Control F5 again. And good, you can see that the emulator is coming up this time. So here we are in the emulator. Now this is a very simple forms type data entry application. I often use it when I'm presenting tombstoning and untombstoning to audiences for the first time. And what I do is I type something into one or more of these input controls here. I'll just type my name, for example, Jeff Procise. Let's get that typed in there using the SIP. And now what I'm going to do is deactivate this application by pressing the Start button in the phone. So in the old days, that is in the Windows Phone 7.0 days, when that happened, the application was almost guaranteed to be terminated, the process completely removed from memory, and all state lost. I'm going to press the back button to reactivate it, and you'll see that the data is still there. In other words, the state of the application wasn't lost. The interesting thing about this is that if you go to mainpage.xaml.cs, you'll find that I have absolutely no tombstoning logic in this application. Its state should not have been preserved. I certainly didn't do anything to preserve it, but the fact that it was preserved was a pretty clear indication that Mango simply made the process dormant rather than completely blowing the process away. But now, what if we wanted to see what happens if the process was actually shut down? Well, I'm going to go to that property sheet that I mentioned a moment ago. Let's right-click the project here, select Properties, and then I'll go over to Debug, and I'll check the box that says Tombstone upon deactivation while debugging. And again, what this tells Visual Studio to do is if we're doing a debug run of this application and the application is switched away from, we're asking it to treat it like a Windows Phone 7.0 app and completely remove it from memory. And now, because I have no tombstoning logic in this app, if I do a debug run, we should see some very different behavior. So let's start the app again. And once more, I'll type my name in. To save time, I'll just type the first name in, Jeff. I'll press the start button on the phone to deactivate it. And then when I press the back button to reactivate it, we see that the application state has been lost. Why? Because the application wasn't made dormant this time. It was completely shut down, just like it was in the old days. So what does this mean? Well, what it means is we need tombstoning logic in this code. The fact that it's running on Mango and targeting Mango doesn't mean we'll never need it, because under low memory situations, for example, Windows Phone may decide to shut your process down completely when the application is switched away from. So let's do this. Let's stop that debugging run there, and let's build some simple tombstoning logic into this application. It shouldn't be too hard to do. In fact, the state of this app that we need to preserve is simply the contents of those three text boxes that you saw. If we look over in mainpage.xaml, we'll see those text box controls being declared. Let's look at them real quick. Give Visual Studio a moment to catch up with us. There we go. Shrink that down so we have a little more real estate. And then let's look in mainpage.xaml, and indeed you see the three text blocks right here. Now, since I'm going to be interacting with them, let's give each of them a name. We'll call this first one the name text box. I'll call this second one here the one in which I ask the user to enter a phone number via phone text box. And then for the final text box, whoops, I meant to do that on the text boxes, not the text blocks, so let's just move that real quickly. I made the same mistake on the one up here. I want to put the names on the text boxes, not the text blocks. And then I'll do the same thing with this final text block or text box that you see right here. This one we'll call the email text box, because this is the one in which we're asking the user to enter an email address. Now that I've assigned names to those text boxes, I can refer to them by name in my code behind. So let's go back to mainpage.xaml, and let's write some tombstoning code. And the rules for doing this are no different than they were pre-Mango. So first thing I'm going to do is override a couple of virtual methods, on navigated from and on navigated to. So there is on navigated from. I'll even get rid of this call to the base class version of the same method, because it turns out nothing is actually done there. Let's go ahead and override on navigated to while we're at it as well. And because that call to the base class isn't doing anything, we'll delete that. So now we have the framework for our tombstoning code. Bottom line is, each time this page is switched away from, the virtual method named onNavigatedFrom is going to be called. That's where I'll write my state out, and I'll write it out to the page state repository. And each time this page is displayed or the application is reactivated, since it's a single page app, the virtual onNavigatedTo method will be called. Now, let's do this. One thing I often do to make my tombstoning code as clean as it could possibly be is I add a simple class to the project that I can use to store all the state for a given page, or for the application, or maybe for a number of pages. So what I'm going to do real quickly here is just do an add class. And I'll call this class something like demo state. And then we'll just add some simple public properties into it. One will be called string, and we'll call it name. And I'll let the compiler write the getters and the setters for me. And then I'll do the same thing with a couple of more properties, but I'll call them phone and email rather than name. So there I have a simple class that I can instantiate to store this state. Now, let's go back to mainpage.xaml.cs. When the application is switched away from, we have no way of knowing at this point in time whether the process is going to be terminated or simply made dormant. So we have to assume here, even in Mango, that we do need to tombstone our data. So here's what I'm going to do. I am going to create a demo state object like this. We'll call it, we'll just call it DS, and I'll new up an instance of that demo state class. And we'll just use member initializers to initialize the properties that we built into it. So we'll initialize its name property to whatever the user has typed into the name text box. And we'll do the same for the phone property. That will be the phone text box, like this. And finally, we'll do the same thing for the email property, and that will come, of course, from the email text box. So if I've done my job there, that should have initialized that demo state object, and now we'll simply write it out to page state. So I'll say this.state, and let's see here, we'll give it a name. We'll call it my state, for lack of a better term, equals DS, so that that state will get serialized into page state and handed back to us when the app is reactivated. Now, the other half of the untombstoning logic will be doing this. I'll make sure that there is a demo state object. So let's do this. I'll do demo state, and I'll call it DS to be consistent with the code above. And we'll say, let's see here, we'll reach into the state property of this page, and we'll pull out my state. And let's see here, we'll say if DS is not equal to null, just a little defensive coding there to make sure that we got it out. Then we will write back into those three text boxes what we got out of state. Notice the squiggly lines here telling me I need to do a cast. So I'll just do it this way. I'll just cast to demo state. That will satisfy the compiler right there. Now, what will we do? We will reinitialize those three text boxes like this. The name is the property that I want. We do the same with the phone text box. That'll be ds.phone. And we'll need to do the same for the email text box. It'll be ds.email. So some simple tombstoning logic. Again, nothing different here about Mango as compared to version 7.0. We're just making sure that when the page is navigated away from, we roll up any state that we're going to need to reapply if and when the app is reactivated, and we write it into page state. And then each time the page is displayed or the app is reactivated, we reach into page state, pull that state that we wrote into it out, and apply it to the application. Now, let's make sure that much works. So once more, I'm going to do a debug run of this application. We'll launch it in the emulator. And I still, whoops, key not found. That's interesting. Well, I'll tell you what we'll do. We'll go about this in a slightly different way. Yes, in fact, I should have been even more defensive about this. Let's change this code just a bit. What I'm going to do is this. So let's see. I'll say if this.state, and I'll use contains key. The problem there is what we're essentially doing is reading from a dictionary, and in the Silverlight for Windows Phone, like in Silverlight and in .NET, when you try to read a non-existent value from a dictionary, you get an exception thrown, so I'm going to use contains key. So if it contains something called my state, then I'll do this. We don't need that null check there anymore, but I will pull this line of code down and place it inside the if statement like this. Meant to do a control V there. Let's get that right. So I'll uncomment that, and now should work this time around. We're making sure that there is something called my state in the page state dictionary. And if there is, then we're reading it out and applying the state to the controls. So one more time, let's do a start debugging. Let's run this thing in the debugger. And by the way, I should still have the box checked that says that we do want to tombstone while debugging, so you can see there that it is checked. Let's go back to the emulator. And what we should find is now when we enter state and we switch away from the app, even though we are now forcing it to be terminated as opposed to simply made dormant, state should be preserved, because when we come back, our tombstoning code is restoring that state. So, all fine and good. In fact, there's nothing different about this than what you would have seen had I done this demo on Windows Phone 7.0. But here's what you need to know as a developer, folks. Let's shut this down. This code works just fine. And this is why I said earlier that if you write tombstoning code into a 7.0 app, it just works and doesn't technically have to be changed when you bring it forward to Mango. But here's the deal. As I said earlier, when the app is deactivated and on-navigated from is called, we have to assume at that point that tombstoning is going to occur. We don't know whether we're going to be made dormant or terminated, so we have to roll up our state, hand it off to the OS by writing it into page state, as I'm doing here. But when on-navigated to is called, what I'm doing here is I'm assuming that the app was actually deactivated and that I need to untombstone state. In fact, if the app was simply made dormant, which will be the case most of the time, I don't need to execute this code. Now, it doesn't take long to execute this code because it's pretty simple, but you can imagine if I were restoring a 10 megabyte bitmap, it could take several seconds for this code to execute. So, how do we know when on-navigated to is called whether we actually need to untombstone or not? Well, there is that activated event fired up at the application level, not at the page level, that has a property that tells us whether the app was made dormant or not. But as I said earlier, you may never need that event. Here's what you can do. And it's very, very simple. You can just do something like declare a private field here in the Pages Code Behind class, or use something else as local state and check it for null to determine whether it was made dormant or not. Let me show you what I mean here. Let's just declare a simple field. I'll make it private, and let's see, we could use a bool, we could use an int, we could use a reference, could make it a nullable bool, it doesn't really matter. Let's just watch this. We could make it this simple right here. I'm going to make it an integer. I'll call it foo, and we're going to set it to some random value like 33. Now, what I'm going to do down here in on-navigated to is simply this. I'm going to say, in fact, let's make this even simpler. Let's just add another clause to this if statement. We'll say if underscore foo equals not equal to 33, and contains key returns positive, then and only then will we do the untombstoning. Do you see what's going on here? I've initialized this private field here to 33. Actually, no. I'm going to have to do a little bit more than this if I'm going to take this route doing an integer. What we'll do is, let me think about this. Probably should have gone another route on it. Because I'm going to have to change the value to know if I've been untombstoned. You know what? I'm going to change my mind on this again here. Let's do something like this. How about if we use an object instead? Let me get rid of this down here. We could, by the way, I just realized there's a way we can make this even smarter. Why declare a private field when we don't have to? We could use these text boxes and their text properties as state, could we not? We could only do the untombstoning if none of them have anything in them. So let's go down that route just a bit. Let's see, so how do we want to do this? What I often do here in real applications is I almost invariably have private fields declared anyway, and I just check them to see if, for example, a field of type object or something is null. If it is, that tells me the page has been recreated because haven't had initialized that field, and I'll just use that. But we could make this even smarter right here, not even needing a private field. What if we do this? We'll say if name text box dot text. In fact, we can do an is null or empty. How about this? If not, actually, I'm going to have, that's a static string method, isn't it? There we go. I think this will get us there a little bit more directly. And actually, I probably don't want the not there. We want to say, and so I'm just checking to see if there's anything in that one. And I'll do the same thing for the other two text boxes as well. And this ought to make it a little bit cleaner. Let's do the same thing for the phone text box and for the email text box. And what I'm driving at here is this. Let's see. If all of those are empty, then I'll go a little bit further, and I'll go ahead and do the untombstoning like this. So let's just add another clause right here. And what this should do for me is this. If the user has typed something into one of these text boxes, and then the user switches away from the application, but the application is made dormant rather than fully terminated, then when the user switches back to it, what they typed into those text boxes will still be there. So all we're doing is building in a simple test here, so that if we find anything in those text boxes, we'll avoid executing this code right here. In other words, we'll only execute this code if all three of the text boxes are empty. Now, if I've done my job right, what we should find on the outside, in fact, let's do a non-debug run since it doesn't really matter here. Let me go back to the emulator, and from Visual Studio here, I'll just do a stop debugging. I'm going to uncheck this box over in the property sheet, which is actually irrelevant at this point because I'm going to do a Control F5 anyway. We just want to make sure that the thing behaves correctly. And I'll do type in my name again like this. I'll switch away from the application, and I'll come back. You can see that the state is still there. In all likelihood, we didn't do any untombstoning there. In fact, what we should be able to do is this right here. Let's go back and do a debug run. Let's allow the operating system to make the process dormant rather than fully deactivating it. But let's put a breakpoint right here. So F5 to launch it in the debugger again. And I'll do an F5 here because there's no data there right now. Now we go back here. I'll type my name one more time into this box. I'll switch away from the application, and then I will switch back. We see that breakpoint hit, and now let's hit F10 a couple of times to step through. And you see that I didn't execute this code down here. I skipped right over it. And bottom line is, because there was something in the text boxes, I deduced that I had been made dormant rather than terminated, and therefore skipped this code right here. So you don't have to do that. Again, tombstoning and untombstoning code written for 7.0 will just work in Mango, but you can make your Mango code a little bit smarter and avoid having to untombstone state when it doesn't need to be untombstoned. And the greater the volume of the state that you're dealing with, that is, the longer it takes to untombstone it, the better off you are by avoiding executing that code. One more thing to remember is that when on-navigated from is called, there's no way to know at this point. Even the operating system doesn't know at this point whether it's going to make you dormant or terminate you. In fact, it may decide initially to make you dormant, then as the user works with other applications, at some point in time decide to terminate your process. So at this point, you always have to assume that you're going to be that you're going to be fully terminated. So fast application switching, that's what you need to know about it as a developer. Just do your tombstoning code as usual, and then add a little bit of logic to make sure that get back to the slides here. Add a little bit of logic to make sure that you don't do any tombstoning that is unnecessary. So, hope that was useful, but there's a whole lot more to talk about here, so let's move right on here to the next slide. I mentioned earlier that there's a lot of new multitasking support in Mango, so I want to talk about that for a few minutes. Remember that there's nothing in Mango that simply lets an application run indefinitely in the background. Instead, we do measured multitasking. That is, we expose APIs that allow applications to do very well-defined tasks in the background at times deemed appropriate by the operating system. One example is the new Alarm API, which lets you programmatically create alarms like the alarms you may have seen when an appointment comes up on your Exchange server calendar or something like that. In fact, creating an alarm like the one you see on this screen is pretty simple. We first used the new Scheduled Action Service class, specifically its find method, to make sure that the alarm that we're about to create or register isn't already created and registered. In fact, in this case, if I find that it has, I delete it so that I can create a new one. Then I create a new alarm object and initialize a few properties. You can specify, for example, how often you want this thing to recur. By setting recurrence interval to none, I'm telling it to occur one time and then not to recur. In this simple example here, I'm programming this alarm to pop up 30 seconds after it's registered. I did that for testing purposes in real life. You know, you may want to have it pop up at some time much further into the future. You also have the option of having a sound play when the alarm pops up. Here I'm referring to a local MP3 resource I call cowbell.mp3, which is going to pop up when this alarm sounds. The content property is probably the most important one. That allows you to specify the content that will appear when the alarm pops up. Normally in Silverlight, when you see a property named content, that means the content can be anything. But in fact, this content property is a string property, so the only thing you can show to the user in that alarm is a string of text. But the key is the very last line of code where I call scheduled action service.add, and I add that alarm to make the system aware of it. In this case, 30 seconds after I do that, this alarm should be popping up. Closely related to the alarm is the reminder. In fact, there's not a whole lot of difference between the two. One big difference, however, is that if you create a reminder rather than alarm, you can take advantage of deep linking. In other words, not only can you have the application that registered this reminder activated when the user touches the little pop-up reminder window, but you can pass data through a query string to have the application launch itself in a particular state. So here's an example of how you create a reminder. The API is very much like that for creating an alarm. The difference is I'm creating a reminder object this time. And notice the navigation URI property, where I'm not only identifying a specific page within my app that's to be deactivated when the reminder appears and the user touches it, but I'm also passing some information in a query string. Here, this query string is a simple one that reads text equals this is a friendly reminder. Now, in this example here, I'm showing in that page that I provided or identified through Navigate URI how I can get access to that query string when the page is activated. You recall that I used the name text for that query string parameter. Here you can see that I'm going through navigation context.queryString, checking to see if there is a parameter named text, and if so, it looks like I'm just writing it out to a XAML text block or something like that right here. Now, alarms and reminders are one form of multitasking, but another form is something called a scheduled task. Developers told the Windows Phone team that they wanted to be able to do things in the background, do background audio, for example, background file transfers, background this and that. Maybe you want to build an application that wants to go back to a server and resync a bunch of data, but maybe you only want to do that when the phone is plugged into a PC or sitting in a cradle at night, so that it doesn't take away CPU cycles from a foreground application. So what Microsoft decided to do is give us something called a scheduled task, of which there are two types. There are periodic tasks, and there are resource-intensive tasks, also known as on-idle tasks. If you register a periodic task, basically you provide some code that you want to execute periodically, and the operating system will decide when or if to run that code. Now, nominally, it will allow that code to run for up to 25 seconds every 30 minutes. That every 30 minutes isn't cast in stone. It could vary by 5 or 10 minutes depending on what else is going on in the operating system at that time. If a periodic task crashes twice, the phone will actually unschedule it so that periodic task will no longer run at all until the user goes back and schedules it to run again. Now, periodic tasks are basically designed to do things that aren't resource intensive. Maybe you're building an app that wants to wake up every 30 minutes, make a call out using the network stack to a service somewhere to find out if there's a tornado coming, and alert the user if there is. That would be a great kind of application for a periodic task. The resource-intensive task is very different. Resource-intensive tasks, by design, only run when certain conditions are true. Only, for example, when the phone is plugged into an AC power source. Only when it has access to the network, either through Wi-Fi or through the network stack of a PC that it's currently plugged into. In other words, a resource-intensive task will not run if the only network connection available is a cellular connection. Microsoft designed the resource-intensive task with the idea that a lot of us plug our phone in at night to charge up. We may even plug it into the PC. And that would be a perfect time to perform resource-intensive background chores, like connect to a server to do heavy synchronization of content or something like that. So your choice is between a periodic task or a resource-intensive task. An application can only register one background task, but that one background task, as you'll see in a moment, can be both a periodic task and a resource-intensive task. Now, before we look at code, I want to say a word or two about what these tasks are allowed to do. Bottom line is, code running in the background in a task can do almost anything as long as that anything doesn't involve the UI or a device. You can't access the camera, for example, from a background task, nor can you access the accelerometer. You can't interact with XAML. You can't display something on the screen for the user to see. In fact, another constraint placed on resource-intensive tasks is that if the phone's screen is on, the resource-intensive task only runs if the screen is currently locked. All other APIs you can use. You can pop up toast notifications for the user. I'll show you how to do that in a moment. From a background task, you could use the location API. You can use the networking API, the sockets API, isolated storage. You can do all of that stuff. You just can't do anything that involves the UI. So, suppose you want to register a periodic task to run in the background. How do you do that? Well, you do what I'm doing here. It's very simple. You create a new periodic task object and you give it a name, and you call scheduled action service.add, just like you did for alarms and reminders, to schedule this periodic task. If you wanted to schedule a resource-intensive task instead, you could do the same thing, but instead of creating a periodic task object, you create a resource-intensive task object, as you see me doing right here. Now, that begs the question, where is the code that's going to run in the background? Where is the code for the task? Well, what you do is, in Visual Studio, you add to the Silverlight for Windows Phone project a new project that is of type background task. It's one of the project templates that you'll see in Visual Studio 2010 once you've installed the Windows Phone 7.1 SDK. In this screenshot on this slide here, you can see that project. I called it Sample Scheduler Agent. And when Visual Studio adds that project to the solution for you, it will give you a class derived from the framework's Schedule Task Agent class. And in that code that Visual Studio has generated, you'll see that a very important virtual method named onInvoke has been overridden. That is where you write the code that you want to execute either periodically or in response to a resource-intensive task. In other words, this is where you put the code you want to run in the background. Remember, for a periodic task, you can run up to 25 seconds at a time. But if what you're doing takes less than 25 seconds, you should call notify complete, which you inherit from the scheduled task agent class, to let the operating system know that you're done for now. That won't prevent your scheduled task from running the next time and the next time. It just says to the OS that for now I'm done, so wait for till the next 30 minutes or so and call me again. Although not shown here, there's also a method named abort that you inherit from scheduled task agent. If something goes wrong and you want to prevent this task from being run again, you can call the abort method. Not only will that end this task for now, it will remove it from the scheduler so that it won't get to run again unless the user does something with your app to cause the task to be scheduled again. Now, that onInvoke method is called regardless of whether you're a periodic task or a resource-intensive task. I mentioned a moment ago that it is possible for one task to be both periodic and resource-intensive. Here's how you do that. Notice the scheduled task parameter passed into the onInvoke method. If it is a periodic task, that tells you you've been called as a periodic task. In other words, you've been called because you scheduled yourself to be called for a few seconds every 30 minutes or so. But if you find that task object is a resource-intensive task, then you were called because the phone is idle, the screen is locked, you're connected to AC power, you have a non-cellular network source, etc. This would be a good time to do that heavy synchronization or something that you needed to do. One of the many, many things you can do with a background task is pop up a toast notification. If you've ever received a text message on your Windows phone, you've noticed the little bar, usually blue, but that changes if you've changed the accent color. But the little blue bar that appears at the top with that text message, you touch it and it goes to the text messaging app. You can now display those toast messages programmatically using the new Shell Toast class, and that's exactly what I'm doing here. So here is a periodic task. And what I'm doing here is just assuming that I'm going out to a network service somewhere, finding out that there's a severe storm in the area, and I'm letting the user know about that by creating a shell toast object, stuffing some message text into it, and calling show on it to show it to the user. Then my application will be activated if the user then touches that toast notification on the phone screen. In fact, I've got an example of that. Let's go over to Visual Studio, and I'll pull it up for you. So I went to open a new project here. Looks like it's still running, so I'll tell it to stop. Then I can open a new one. This is another of the projects that I'll make available to you for download. It's called Background Task Demo. And it does pretty much what you saw there in the slides, in that it registers a periodic task, and in that periodic task, which is in the Sample Scheduler Agent project, if you look in taskscheduler.cs, I'm using the Shell Toast API to pop up a toast notification. I'm not actually going out of the network to see if there is a storm coming. I'm just pretending that there is, but I'm asking the OS, once the toast notification pops up, if the user touches it, to activate mainpage.xaml in my application and to pass this query string data here, presumably so that I can make another call out and go get the up-to-the-minute weather for that location and show it to the user. Now, when we run this thing, here's what we'll see. Let's do a Control F5 to get it running. Pop over to the emulator here. Let's try it again. Maybe VS didn't have the focus. And let's see. Oh, I just realized, I'm sorry about that. You're right. I'm not sharing. Thank you so much. Let's go back and do that. I need to share my desktop so you can see what I'm doing. So let's do that. Now I've shared the desktop and I'm back in Visual Studio, and you see this project here called Background Task Demo. That's my Silverlight for Windows Phone project. I've also added a background task project to it called Sample Scheduler Agent, and I'm currently looking in taskscheduler.cs and looking at the code, again, very much like the code you saw on the slide, to do something every 30 minutes or so when this thing gets a chance to run, specifically to pop up a toast notification to the user. Now, let's run this in the emulator. And let's see here, interesting. It's grayed out all of those options. Let me do a rebuild on it to see if that will make Visual Studio just a little bit happier. And error list looks clear. So let's see if it'll now let me run this thing. It'll let me start a performance analysis, but it won't let me. Oh, I know. It's because I have this project as the active project. It needs to be background task demo. Let's make that the active project or the startup project. Now, if I do a Control F5, we'll see it come up in the emulator. When I click the button, I just executed some simple code to register a periodic task. Now, the funny thing is we can't actually see it run right now because it's going to be roughly 30 minutes. So what I'm going to do is leave the emulator running, and hopefully, if our timing is just right, about 30 minutes from now, as we're closing the presentation, we'll see a toast message pop up that tells us there's a severe storm coming. So we'll just check back on the emulator to see if indeed that happens. Okay, let me pop back to the slides and start into the next topic then. So right back here to PowerPoint. I'll do my best to remember to share my desktop out next time, and we'll pick up on the slides where we left off. One of the most important new features in Mango, in my opinion, is HTML5 support. Why is that so important? Because if you want to build cross-platform mobile applications, HTML5 is the way that you will most likely do that. Now, you may use other frameworks, JavaScript frameworks on top of it. You may use jQuery Mobile, for example. That actually makes life a lot easier building cross-platform mobile apps. You might even choose to use tools like Google's App Mobi to help you out, or tools like PhoneGap, which not only provide a JavaScript framework sitting on top of HTML5, but also provide JavaScript APIs for accessing native operating system services and sensors and other services on the phone. But what I want to show now is how to use HTML5 to build a cross-platform mobile application. We'll run it, of course, on a Mango phone. So take a look at this piece of code here. This is how you package and deploy an HTML5 application for Mango. First, you declare a web browser control. That's your entire UI, just a web browser control. And since an HTML5 app is invariably going to have JavaScript in it, you need to be sure to set the web browser controls is script-enabled property to true. Now the challenge is to take the page and perhaps other assets like images, style sheets, JavaScript files that constitute the assets for your program, and to write them into local store or into isolated storage as virtual files. What you see me doing in this example is writing index.html, the HTML5 page that comprises this app, into isolated storage. If there were other assets, images, JavaScript files, etc., I would write those in as well. Then, after the web browser control fires a loaded event, I set its source property to the local URI of index.html in isolated storage. There's something very profound happening here. To package an HTML5 app as a native app in Mango, you deploy through the marketplace a native application. But in that native app, you fire up a web browser control, write the HTML5 assets that comprise the app to isolated storage, and then point the web browser control to the home page, if you will, in isolated storage. The cool thing is, if, say, in index.html, I have relative links to other pages, script tags pulling in JavaScript files, image tags showing images, if those are local URIs, they will be resolved right there in isolated storage. So let me show you an example. I'm going to share out my desktop again, and go back to Visual Studio, and I'm going to open a project here that I call HTML5 Demo. So let's open it, and before we look inside it to see what makes it tick, let's run it to see how it works. So I'll bring it up in the emulator, and what you're going to find is that it's one of these applications that has a puzzle with moving puzzle pieces. I can touch one of the puzzle pieces next to an empty square, and the puzzle piece slides down. So if I do that enough, I'm going to scramble this puzzle pretty well, and if I'm really clever, then maybe I can rearrange it. I'm not very good at these things, so let's see if I can kind of undo that and rearrange. You can see the puzzle pieces sliding around. I think I'm going to get there. Look at that. Oops, no, I'm going to have to go back and do it over. I didn't do a very good job, but you get the idea. What's interesting about this application is that it is an HTML5 app wrapped in a native application that can be sold or distributed for free through the Windows Phone Marketplace. Let me show you in Visual Studio what makes this application up. I began by creating a normal Windows Phone Mango project. Then I added an assets folder, and I placed all of my HTML assets in there. In this example, those assets consist of a page named puzzle.html. That's an HTML5 page. It's the one you were seeing a moment ago in the app. jQuery.js, like many HTML5 apps. This one uses jQuery to abstract differences between browsers. That's going to be important if you want this to run on an iPhone or on an Android device, for example. And scene.jpg, which is the image that I programmatically cut up using the HTML5 Canvas API into the little movable squares that you saw. Now, in mainpage.xaml, there's a little more than a web browser control. You can see that here. It's filling the entire screen. In mainpage.xaml.cs, I'm doing what I showed you in the slides. When the application starts up, I check to see if those HTML assets are in isolated storage already. If they're not, I write them in there. Then, once I know that they're there, when the web browser control fires a loaded event, I set its source property to the local URI of puzzle.html in isolated storage, and lo and behold, that website is running from local assets on the phone. It's not having to go out and pull them down from a real website or anything. It's just there on the phone. The user has no idea that it's an HTML5 application, as opposed to a native application. If you wonder a little bit more about, okay, how do you implement the UI and the logic, well, look at puzzle.html. I won't go through all of this, but I'll hit the highlights. And remember that I'll give you a URL in a few minutes that you can download this and the other samples from. What you see if you look in here is this. In HTML5, the UI for this application is a bunch of canvases, each measuring 160 by 160 pixels. Each canvas represents one piece of that puzzle. If you look at the JavaScript code up here in jQuery's document ready function, I programmatically load that image, scene.jpg, and then I use the Canvas API in HTML5 to cut the image up into 160 pixel squares and draw one piece of the larger image into each of those canvases down below. Then I use jQuery's click method to wire up a click handler to each of those canvases down below. Here is the click handler. And all I'm doing is, again, using jQuery, specifically using jQuery animations. Notice the call to jQuery.animate here, to move the piece that was touched left, right, up, or down by 160 pixels. There's also a little bit of logic here to make sure that the piece that was touched is adjacent to an empty square. Otherwise, I've got nowhere to move it to. But the bottom line is, because all of the logic, all of the UI is written in HTML5 and jQuery, I could take this application and I could make it run without change on an iPhone, an Android device, or what have you. Now, I could either package it up manually as a native app on those other devices, or I could use tools like PhoneGap, which will do that for me. So, pretty cool stuff, and really, really important if one of your interests, as mine is right now, is learning to write cross-platform mobile applications. Now, let's go back here. I'm going to pause for just a moment and check for Q&A, see if anyone has asked any questions. So it looks like there's nothing in there right now. And what I'm going to do then is go back to the slides and go just a little bit further. The next feature I want to present is secondary tiles. Kind of an unheralded new feature in Mango, I think, but one that I'm particularly fond of because I think users are going to love it when you leverage these things in your applications. What is a secondary tile? Pretty simple. In Windows Phone 7.0, as you're probably aware, the user had the option of pinning an application to the start screen. It was then represented by a tile on the start screen. And became a shortcut for starting that application up. Using push notifications, it was also possible to update the content on that tile periodically. In Windows Phone 7.0, however, an application could never be represented by more than one tile. That changes in Mango, where an application can create any number of secondary tiles, each representing a deep linked shortcut into the application. I'm going to show you an example of that in a moment, but before we talk about why this is useful, let's see how you leverage this syntactically. If you want to create a secondary tile from your app, and by the way, this is something that can only be done by the application. There's no UI for doing it in the shell. This is how you do it. What I do is create a new standard tile data object. Not surprisingly, that's a new class in Mango. And I initialize a few properties. Background image, for example, refers to the image that I want to use as the tile background. That's not required, but it's something in this case I wanted to use. The title property lets you specify text that appears in the lower left corner of the tile. And if you want an integer display, you can use the count property to do that. If you set count equal to 0 or simply don't set count, then the integer is not displayed. Then I call shell tiles static create method to register this tile. And notice the URI that I pass in. I'm simply saying to the OS, if the user touches this secondary tile, I want my application activated, and specifically I want a page named weather.xaml displayed, and I want to pass into it the query string zip equals 98052. So the context I'm using here is that of a weather application. The user may want to be able to quickly check weather in 4 or 5 different locations. If you provide the UI to do it, the user could create a tile shortcut on the phone's start screen for each location they're interested in, and then just touch the tile that they want to see detailed weather about when they want to see that data. I'll show you that in a demo in just a moment. By the way, after you've created a secondary tile, you can also update it using the shelltile.update method. You can see me using that right here. You can also delete a secondary tile programmatically. And by the way, if the user decides they don't like the secondary tile and want to get rid of it, they can get rid of it the same way they get rid of a primary tile, by pressing and holding that tile and then touching the unpin icon that appears next to it. One other thing I want to mention, at least in passing, new in Mango is the ability to create two-sided tiles. In Mango, when you create one of these secondary tiles, there are some additional properties with the names background image, back title, and back content you can set to put information on the back of the tile. Now, there is no API for flipping the tile from back to front, but when a tile has data on the back, the operating system itself will periodically rotate that tile so that the user sees what's on the back. If you've used a Mango phone, you may have seen that because some of the built-in applications use that already. So once more, let me share out my desktop and let's go back to Visual Studio. So I'm going to open another project this time, this one called Secondary Tile Demo. And I'm going to show you how an application might use these secondary tiles. So let's look at it from the user perspective first. So I'm going to launch it in the emulator. Looks like I'll need to do a rebuild here. No problem. Here it is in the emulator. And one thing I'm going to do just to make it look nicer, you notice that they've changed the default accent color in Mango from blue to red. That looks a little bit harsh to me, so I'm going to change the accent color back to blue, kind of like it that way. Blue is my favorite color, as it turns out. And let's just relaunch the application, Secondary Tile Demo. Now, what this one does is it allows me to get weather at a given location. In fact, it actually goes out to a live REST weather service and pulls the data down. I live in a little community outside Knoxville, Tennessee, where my postal code is 37934. So we find out that it's actually 91 degrees outside right now, pretty hot. But watch this. I'm going to press this plus button in the application bar. I just created a secondary tile representing this particular location, which now appears on the start screen. But now let's go back to the app. And let's go grab the weather at another location, maybe, for example, 98052, which some of you will recognize as Redmond, Washington. So there, it's currently 63 degrees, and I'm going to click this button in the application bar again to create a secondary tile for it. Now let's do that one more time. I'm going to enter the zip code 12354, which actually represents a little place called Schenectady, New York, which I've never been to, but they do have an easy-to-remember zip code. Looks like it's currently 79 degrees there. I will create a secondary tile for them as well. So take a look here. This application now has 3 secondary tiles on the start screen, each representing a particular location. If I quickly want to find out what the current temperature is in Redmond, Washington, I click that secondary tile, my application is launched, and I passed in via query string the zip code 98052. The application took that zip code and automatically displayed the data at that location. So the beauty of secondary tiles is, number one, providing the user with an easy way to create shortcuts into your app, and number two, being able to attach information to each tile that deep links into the app, that displays a certain page when that tile is touched, and even passes information into that page via query string. If you look at how this thing works, you'll see that I've done pretty much the same thing here that I did in the slides. When the user presses that plus button in the application bar, for example, it comes down to this method. I'm checking to see if there's already a secondary tile that has been created for that particular zip code. If not, I create a standard tile data object, and I call create right here. And the URI that I pass in is that of the main page in the application with the query string key or zip equals the zip code that the user entered. If you look in this page's onNavigated-to method, of course that's going to be called every time the page is displayed, you'll see there that I'm checking to see if there is a query string containing a zip code. If there is, then I'm using it and going out and using it to restore the state of the application. I'm not on tombstoning state. I'm going and grabbing new state based on that zip code that was passed in. So that's one use for these so-called secondary tiles. You may think of others, but again, I think it's a fairly exciting feature. It's one I've already used quite a lot, as a matter of fact. Now, let me go back to the slides. We are almost out of time, but that's okay because I've hit the topics that I wanted to hit really hard, but I do want to spend just a few minutes running through some of the other new features in Mango that you should know about. So, let's do this. There is a Contacts and Calendar API. You can now write code like this to query the contacts that the user has on his or her phone. Notice I'm using LINK to do that. This is a very simple one here that just asks for all the contacts currently stored in the phone who have at least one phone number associated with them, and then I might bind the results to a list box, for example, to display those to the user. There's a similar API, access to the new Appointments class, for accessing appointments on the user's calendar. This code looks very much like the code in the previous slide. Again, I'm using LINK to do the query. Now I can integrate calendar data into my own application, and I won't take the time to show you a demo since we're running short on time, but in the zip file whose URL I'll give you in just a moment, you'll find one called Contacts Demo that does exactly that. It reaches into the user's contacts list and presents sort of a custom UI for dialing phone numbers. Another thing that's new in Mango is several new launchers and choosers. I've listed those here. One of the really cool ones is Bing Maps Directions task. If you wanted to build an application that used the location service, for example, to give the user directions from their current location to, say, the local Starbucks, in the past there was quite a bit of work involved in doing that. Now it reduces to 4 or 5 lines of code. With Bing Maps Direction task, you simply launch the task, give it a starting point and an ending point, and it actually provides turn-by-turn directions on a live map to get the user to where they're going. Never been easier to build that type of application. Save ringtone task. I told you Mango supports custom ringtones. A user can add custom ringtones to their phone, or you can add them programmatically using Save Ringtone task. There are even some new tasks called Share Link task and Share Status task to help you integrate with social networking sites. If you wanted to post a new status or something like that, you could do that using the Share Status task. Here's a quick example of how to use Bing Maps task, how to bring up a Bing map that shows the user's current location. Notice I just new up the Bing Maps task object and ultimately call show on it to show that to the user. Take that to the next level with Bing Maps directions task, and it gets even richer. Lots of new sensor APIs. Well, today's Windows phones tend to only have accelerometers in them, accelerometers and cameras. Future Windows phones, most will have compasses, some will have gyroscopes. There are new APIs to allow you to leverage those things. The compass, for example, the API for it looks like this. You can use the new compass.isSupported property, obviously a static property, to find out if the phone that this code is executing on has a compass built in. If the answer is yes, you can new up a compass object to access the compass, and you can set the time between updates to tell it how often to fire events, apprising you of the direction that the phone is facing. Contrast that to the accelerometer API introduced in 7.0, where it always fired 50 times a second and didn't really give you the opportunity to set the time between updates. I liked what they've done with the Compass API, and they've done this with the Gyroscope API and the Consolidated Motion API as well. But here's a simple example of me taking readings from the compass. Once you call start on the compass object, it fires current value changed events. I'm processing those events here, and looks like I'm showing some of the information coming to me in those events, like the geographic heading and the magnetic heading to the user. Notice I've wrapped that code in a call to dispatcher begin invoke. When that current value change event fires, it does fire in a background thread, so if you want to use the data to update the UI, you have to marshal back to the application's UI thread first. Easiest way to do that is to use dispatcher begin invoke, as I'm doing right here. I mentioned at the beginning that there are lots of new tools. I didn't show you this, but the emulator does have some new tricks up its sleeve. It now has tools to let you emulate accelerometer and location data. You can now, for example, using the accelerometer UI in the emulator, virtually tilt the emulator and see how your application responds to it. There's also more recently added a tool for creating screenshots right there from the emulator. If you look in the tools folder after you install the SDK, you'll find one new tool called Isolated Storage Explorer Tool.exe. It lets you reach into isolated storage on a device or in the emulator and see exactly what's there. One time that's really handy is when you're deploying HTML5 assets to isolated storage. If it's not working the way you intended, you want to make sure that what you think you've written to isolated storage is in fact there. This is the tool that we use to do that. From Visual Studio, you can access the new performance analysis tool and even something called the Marketplace Test Kit, which is really cool. In Windows Phone 7.0, once you submitted an application for testing and certification, it was pretty much a black box. You submitted it, and then you waited a few days, and then you either got a notification that the app had been approved or it had not. But in Windows Phone 7.1, the process is still there. But through Visual Studio, you can run the Marketplace Test Kit, and you can run many of the same tests on your application that Microsoft runs on the application when they put it through the certification process. What this is going to do is allow you to very easily make sure before you submit the app that it really is ready to be submitted. Now, if you pass the test in the test kit, that doesn't necessarily mean you'll be approved, but it does increase the likelihood that you will be approved. And there are other features that I haven't talked about. There's Visual Basic.NET support now. There's an Enhanced Device Info API. You can find out who your cellular operator is, for example, or whether the phone is currently plugged into an AC power source. You couldn't get that information in Windows Phone 7.0, but it can be very useful if you're going to do something that's very resource intensive, like go out on the network or something. You may decide not to do that right now if you find out you're running on battery power, or maybe it's you're building a location enabled application, and you don't want to drain the phone's battery by asking for a continuous stream of GPS coordinates if you're running on battery power. So now you can find out whether you're running on battery power or not and respond to that intelligently in your application. As I mentioned earlier, there's a new low-level camera API, which is very cool. A new local database API, which allows you to write relational data into isolated storage and read it back. The system tray now has a few tricks. It has a built-in progress indicator. There are also some late changes, by the way, to application bars, which can now be minimized and can be made partially transparent and all that. There's even a new encrypted credential store, so that if you're building an app that integrates with Facebook and you ask the user for their username and password, rather than perhaps compromise that data by storing it in isolated storage, you can now ask the operating system to store that username and password encrypted to protect it. Not a lot of documentation on that yet, but it is there, and I expect it's something that developers will want to know about. One quick example here, if you want to know how do I find out in my code whether I'm running on battery power or connected to AC, here is how you find that out. Notice I'm using the new device status class to get this information. Power source is one of about a dozen properties in it that you can find out more about the current state of the device that you're running on. Last thing, if you want copies of these samples that I showed you, here is the URL. www.winelike.com/downloads/mangodemos.zip. The zip file is already present. I checked it a couple of hours ago to be sure. You can go there at your convenience and do the download, and I'll leave that active for at least 30 days or so. But you'll find all the demos that I ran there, as well as a couple of others as well. Hopefully something to get you started on Mango there. So I'll conclude by thanking you for your time. I hope this has been somewhat helpful to you. Love to see you at Discovery if you'd like to. Discovery is a series of conferences that we at WinElect put on every year in various locations. The next one is coming up in October in Austin, Texas, which has the best barbecue I've ever had. John Robbins, Jeffrey Richter, myself, and several others will be talking about all sorts of topics there. HTML5, jQuery, Mango, Azure, you name it. If it's new and cutting edge, we'll probably be talking about it. Wow.
Well, great presentation, Jeff. Thanks very much for that. And some stuff that I didn't know, but then again, I've not done much with Windows Phone 7 yet. You've got a question in the Q&A there from Satish.
Let's pull it up then. Let's see. Okay.
I think he's on about the tombstone and stuff.
I see it here now. In the tombstoning sample, can we rather set the state object to null after the app is brought back from tombstoning and the saved values were set to the fields? Can we set the state object to null after the app is brought back? You could set it to null, but if I'm following the question correctly, that is not going to give you the results that you're looking for. I bungled that a bit by changing my mind about what I wanted to do. What we typically do there, Satish, is since we invariably have private fields in the code behind class, we take one whose type is that of a class rather than a struct, and we check it for null, because when the app is restarted from scratch, that is, the process is restarted from scratch, that value will be null. Whereas while the app was running, if we assigned a non-null value to that field, but then the app is deactivated and made dormant, when the app is reactivated, we'll find that that value is still there in the field. That's the key. Just take a private field, check to see whether it's null or not. If it is, that tells you that the app was restarted, so you need to untombstone the state. If it's not null, that tells you the app was not restarted, so you can skip all that untombstoning code.
All right, any more? I know we only have a few attendees today. But guys, feel free to shoot your questions if you want. We've got a couple of minutes. Yes, no. If you've got a microphone, since there's only 3 of you, pipe up by all means and do an audio question if you want.
Here's one more question, and the example for alarms is the alarm name sample alarm unique across the scheduler service. It's actually not unique across the service. It is unique within your application. It's perfectly fine, Satish, if 2 applications register an alarm with the name sample alarm. They're scoped by application. Good question there, by the way.
One more, G-Bond.
Yes, does VB.NET support the same as C#? That is it fully functional? It absolutely is. How about that? Yes.
Sorry, I've got to laugh at that one.
Yeah, well, you know what? It kind of tells you we are suspicious sometimes, aren't we, when we hear Microsoft say we have VB support. Yes, I believe you'll find
Definitely.
that the VB support is every bit as functional as the C# support. There's nothing left out, at least not that I'm aware of.
Yeah, I fondly remember my trials and tribulations with Pocket PC 2003 and the
Yes.
early builds of the SPV and the SPVE 200. Wow, that was torturous. But yeah, I mean, once again, very good presentation. Thank you very, very much for coming along. We'd love to have you again in the future, Jeff.
Love to come back. Thank you so much.
We've got another question there.
Yeah, it says check to see if the scheduled task popped up. That's a great reminder, and I'm looking at the emulator right now. I realize you can't see it, but I'm looking at it. It's not there, but what probably happened is once it pops up, it goes away after a short period of time if it's not touched. So unfortunately, I didn't have it open at exactly the right time to see it. So it's not there.
It's gone. It's dead. Seesaw life or no more.
It's a ghost.
It's yeah. I mean, it really does look like a nice platform. I've got some up and coming projects that I really need to get stuck into. So it looks like I'm definitely going to be catching up on my Windows Phone 7 stuff. Diego, you have your hand up. Are you wanting to ask an audio question? If you are, just unmute your microphone and speak up, my friend. Yes? No? No? Okay, no worries. And Satish is asking about the toast sample now.
Yeah, the toast sample, how will the toast object pick the application to turn on? So you didn't actually have to identify the application. The operating system knows which application called the method to display the toast notification. It's the OS that makes sure that the right application is activated.
I do have to laugh at the fact that they called it toast.
Yeah.
I don't know if anybody actually knows where this terminology comes from, but you find a lot of these desktop notifications, phones, desktop, whatever, called toast. And this might be going back quite a bit for some of you, but these originally came from a screensaver for MS-DOS that heavily featured flying toasters. I can't remember the name of the company that did it, but they had a little application that came with the said screensaver that ran as an old-fashioned Terminator Stay resident, and it was called Tea Timer. And whenever your alarm was set to go off, Tea Timer would pop your toast up on the screen.
I remember that screensaver, and I think it came from a company named After Dark, did it not?
That's the one.
That's it. I used to run that screensaver.
Yep. Well, that's where toast notifications came from, and the terminology known as toast has stuck with us ever since.
After Dark, boy. Talk about a blast from the past.
A little bit of history for you all.
Mm-hmm.
Right, well, I have to go. It's getting on quite a bit here in the UK. Once again, thank you very much. For those who didn't attend, we will have the presentation up online on www.lidnug.org. Please remember that you have to put the www in front of lidnug.org because we still have the old DNS address registered, and just lidnug.org on its own will take you to a completely crashed whole barrel of mess. So lidnug.org, go into archives. We'll have the recording up there, hopefully within the next 2 to 3 days. As soon as Brian gets back from swanning around in TechEd Australia. And Jeff, if you want to email me the link and possibly email me a zip of the demos, providing they're not too big. We can probably put them up there to download with the presentation as well, so
Sure.
that they'll stay around for a little bit longer than 30 days.
Okay.
On that point, I'd like to say goodbye to everybody.